The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
Microphone on. There we go. Okay. Well, welcome everybody. My name is Thomas Cameron. I am a senior principal solution architect at Red Hat. I actually work with Ansible primarily, automation, but I really enjoy playing around with other stuff, which is why earlier today I did a presentation on Red Hat Satellite, and now I'm going to do OKD because I'm a big old nerd and I don't get out much. So thank you for being here. What I'm going to talk about today is I'll do a quick introduction. I'm going to talk about where I got some of this knowledge from, because you got to give credit to folks who have built the community. I'm going to talk about setting up OKD with physical hardware in a lab type of environment. You could do this, in a home lab or something like that. So we're going to talk about network configuration, DHCP, setting up DNS, because you really need to have good resolution for your cluster. We're going to talk about how to put an OKD cluster behind an HAProxy environment, how you can use shared resources or shared storage like NFS in an OKD environment. I'll talk about the actual installation, and then I'll talk about some of the post-installation steps. So who am I? Well, I've been doing this. I've been doing IT work since 1993. So yes, I'm old. The beard, the gray in the beard has been well earned. I started out, and this is going to date me, as a Novell CNE. Anyone remember Novell NetWare? Yeah. All right, cool. So I was a CNE on 3.11. Then I went to work for Microsoft, became a Microsoft certified systems engineer, started using Linux in 95. Interestingly, when I worked for Microsoft, there was a guy who worked with me during the launch of Windows 95. I was a technical development engineer there. And he kept talking about this Linux thing. And I was like, I'm going to prove, because Unix is dead, right? I'm going to prove to you that Windows NT 3.5 is better than this Linux thing. You can see how that turned out. Worked at Red Hat for about 14 years. I was a Red Hat certified architect, level 5. Then I went over to AWS for a few years, became an AWS certified solutions architect, and then realized I had lost my mind and came back to Red Hat. And so I am here, and I plan on retiring from here. I do want to make clear, y'all, I am not an OKD or an OpenShift maven. Like, I'm not an expert. I still beat my head against the wall sometimes. And honestly, the whole reason that I put this slide deck together was because trying to figure out how to do this on bare metal was a nightmare, because the documentation is amazing as a reference guide. The documentation is not very prescriptive. In other words, it'll tell you, here are the 18 things you can do, but it won't say, here's the one thing you really should do. So this is my experience. This is what I have made work. Your mileage may vary, and the only thing that I guarantee is that if it breaks, you get to keep all the pieces. All right. So first off, big ups to a gentleman by the name of Ryan Hay. You can look at his GitHub repository. I did almost all of this based on some of the advice that he gave me, or he posted on YouTube and things like that. So the thing about setting up OKD is, if you want a production style setup, you need to set up multiple networks. You need to set up DHCP, DNS, all those types of things. So let me show you what I did to set this up. So I set up 2 physical networks, a quote unquote production network and a private network. On On the production network, I already had existing DNS, DHCP, PXE boot, all that kind of good stuff. Then I set up a private network that was a 192.168 network, and I needed private DNS, private DHCP. The only connection between the two networks was an HAProxy machine. Now, in this case, it was actually a virtual machine, but I had one network interface on the private network, one network interface on the public network, and that's what it wound up looking like. So the middle box that was running the virtual machine is actually a big HP ProLiant machine, and those little Intel NUCs were behind the Intel or behind the HP ProLiant. So the HAProxy was a tiny little machine, 4 processors, 4 gigs of memory, nothing super fancy. I kickstarted that off of the production network. And so it had an IP address, it had a DHCP reservation. So the public IP address was always fixed. On the internal interface, it was unconfigured. So you can see that I did NMCLI device status, and you can see that the secondary interface was just not connected at all. So I used NM2E, went in to edit the connection, went to that new interface, changed it from a DHCP configuration over to a fixed address. So it's always going to have the right IP address on the private network, right? So 192.168.1, and I set the DNS server for that subnet to be the HAProxy machine, because it's available to all of the machines on that private network. I'm like, let's just do DNS and DHCP and everything there. So made sure I set up the DNS servers, activated the interface. It came up and it was fine. And then I just checked by doing NMCLI device status, and it was up and running, made sure that I could ping that private network, and I just ran an IP brief address show to show that, yep, it's on both those networks. I needed to tell the firewall that those two interfaces are on separate networks. It actually took me a little while to kind of figure this stuff out. So I did firewall command get active zones, and you can see there's just one zone, right? Well, that doesn't help me because I've got 2 networks. So I did, I figured out which one was on the private network, which one was on the public network, and I used NMCLI connection modify this interface to be connection zone internal versus connection zone external. So now I've told the firewall these are on 2 separate zones. Now you can see that they're associated with the zones, and you can see that the internal zone, my firewall is pretty much wide open. My external one, though, it doesn't allow anything except just SSH. That's a security thing. This is the step that actually just kicked my butt for a while, trying to figure out how to get masquerading to work between the 2 interfaces. Because it used to be that you would just say, yes, I want to enable masquerading on the external interface, and it would just work. Not anymore. So what I had to do was I had to create a policy called internal to external. I had to add the ingress interface. I had to add the egress interface, which is basically just telling firewall rule, this is inside versus outside. Then I had to set the priority. I had to set, set the target, set the priority, make sure that masquerading was turned on. It was turned on. And then I did firewall command reload. Then once I was able to do that, I could do firewall command info policy, and now you could see what the priority is, where the ingress zone, where the egress zone is, and everything started working. Then I could look at the external zone, make sure that all the ports were open that I needed to be, and then what I needed to do was set up on one of the controller nodes. I just needed to make sure that I could log into the machine, make sure that it could ping the rest of the network on the private subnet. So you could see that I was able to ping out to the internet and get traffic back through the masquerade zone. So it all worked out. Now, I used DHCP on the external network. I could have done static addressing on the internal network. That would have been perfectly fine, but I hate like having to manually configure stuff. So I set up DHCP. I decided to do it on the proxy server just because it has an interface on the network. So DNF installed DHCPD or DHCP server. And then I had to edit the dhcpd.conf file. So the first thing is, well, it's blank. So then I had to set the global variables, and these are straight out of the documentation. Then I had to define the subnet, the 192.168 subnet, set up an IP address range. I then had to, or I decided to set up DHCP reservations, right? So the bootstrap machine is always going to be at 200. The control plane 1 is going to be 201. The control plane 2 is going to be 202, blah, 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 blah. So I set up DHCP reservations. Then I started the service, made sure that the DHCP listener, or the DHCP port 69 was open, and it was. Enabled DHCP, and then moved on to the next thing, name resolution. Again, I could have set up an etc hosts file. Like, it would have worked, but that's not, production grade. So I installed bind. Once I got that installed, I edited the named.conf file, and it's pretty standard. The only real changes that I made are that I had to change the listen on port from 127.0.0.1 and allow query from localhost. I had to make those listen on port 53 any and allow query any. So that says the DNS server is now serving the entire subnet. I did enable recursion. Can anybody tell me why enabling recursion on a DNS server can potentially be dangerous? Come on, I got to have an InfoSec person in here. Yes.
That's not dangerous. It's a good thing.
On a publicly facing server, it's not. This one's on the production network. So think in terms of, let's say it's a public server. Right. The other thing is, yeah, if you enable recursion, you can open yourself up to abuse. You can open yourself up to doing things like DNS reflection attacks and stuff like that. So my point here is, don't just willy-nilly read through these slides and say, oh, I'm going to turn my DNS server on for recursion for the whole world, because you may get a phone call from your ISP going, we're shutting you down. Most don't. You have to explicitly go in and set it. But I just want to point out that I did, but it's because it's behind my corporate firewall on the private network. I just want to point that out. I also set up a forwarder so that my DNS server would go ask the production DNS server and so on. And then I just defined the zones, the DNS zones. So I used a bogus zone called, instead of okd.com, okd.lan. That way I know for sure that I'm never going to step on anyone else's zones. And then I set up a reverse DNS zone so that I could do forward and reverse DNS. I did a little diff file. So if you do this, if you get the slides and you want to do this at home, you can double check yourself. Those are the differences between the before and after. And then I created the two zone files under var named. And in those, it's pretty straightforward. The first section is very standard zone file, like the serial number, the refresh, the retry, and so on. I did define the HAProxy, the OKD bootstrap machine, the control plane nodes, the worker nodes, and so on. Now, I did add some fields that used to be required for OKD and OpenShift using the service records. You don't actually have to do that anymore. I was going off an older tutorial and I left it in, but I have since looked, or actually asked the OpenShift team. They're like, no, we don't require that anymore. So just be aware that that's there. And then I set up the definitions for the OAuth and the console for my OKD cluster so that I could resolve those. Now, I do want to point out that for the console, whoops, make sure I don't get feedback. So for the console and for the OAuth interface, they're both pointing at the HAProxy, or I should say the name of those both resolves to the HAProxy. And we're going to set up the HAProxy to go forward stuff to the actual control plane and worker nodes. It'll become clear in a little while. So then I do the same thing with the reverse zone. If you know anything about DNS, this is pretty straightforward. If you don't know anything about DNS, I recommend that you do, because it's just really cool to understand how DNS works. So I set up the reverse zones. That works. Make sure that the firewall is opened up for the internal network to allow DNS lookups. So 53, TCP, and UDP. I enabled named. I double check and make sure that my DNS is working. So I do host HAProxy, blah, 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 against the internal interface, and it comes back. And then I do the same thing with the IP address to make sure it resolves correctly. So now I know that DNS is set up. Now I need to set up HAProxy. Before I run the installer, I need to set up HAProxy. First couple of times I set this up, not gonna lie, kind of bent my brain a little bit. That's why Ryan documented this. That's why I've kind of cleaned up what he documented. But I installed the HAProxy software. I edited the config file, and I literally just went through and I took either the default settings or I defined proxies for different IP addresses for different services. So those are the defaults, user and group and things like that. Those are global defaults, things like timeouts and stuff like that. Like those are just standard settings, nothing you would really need to spend a lot of time in. Then I did enable HAProxy statistics on port 9000. That way I can kind of look at the HAProxy and make sure that everything is connected the way that I would expect it to be. This is where I get into actually routing traffic between various services. So I define the front end, which is the K8's API front end on port 6443. And it's going to talk to the back end, which is the K8's API backend using TCP. That's one definition for basically one route. Think about it. Then I defined that backend, and I say that backend is going to have these servers, and it's going to be connecting on 6443 because of the stanza above it, which that's how when you install the backend, it'll be listening on 6443. So I set that up. The next thing I do is I set up the machine config server definition. So listening on port 22623, and it's going to talk to the backend machine config server on the back end. Then I define the machine config server backend. There are the nodes that I'm connecting to. So the previous ones were the worker nodes. These right here are going to be the control plane nodes. So if you understand how K8's works or Kubernetes works, you're going to have the control plane nodes, you're going to have the worker nodes, and this is just saying now anybody who connects to .1, the 192.168.122.1 on these ports, it's going to get sprayed out to all of the control plane nodes or whatever. Then I'm going to define the OKD ingress, and then point it to this backend. So again, servers on 211, 212, 213, and 214, and that's on port 80. Then for the ingress on port 443 for SSL connectivity, I'm going to define that to go to the OKD ingress backend servers. And those are, again, 211, 212, 213, and 214, because those are the worker nodes. Once I get all of that done, because I defined all those different port numbers, because the documentation tells you that OKD listens on these port numbers for these various services, then I'm going to run firewall command add service for all of those, make them permanent, and then I'm going to do firewall command reload. And if I play my cards right, then all those ports are going to be open as long as I haven't had any typos. This one bit me. you have to tell SE Linux that it's okay for network traffic to be, I'm seeing heads nodding. Yeah, I didn't catch that. And I was like, boy, this is not working. And I present on SE Linux most years at Red Hat Summit, and I just brain cramped. So like, it's one of those gotchas that'll just, so I turned that on. And then I grepped out to make sure that, yes, indeed, I really did turn it on and that it was permanent. And then I enabled the HAProxy service, and I was able to go to the HAProxy website. Now, if you've ever worked with HAProxy, you know that this is not a good sign because everything's in red. But it's actually expected because we haven't even spun up OKD yet. But this just tells you, hey, I'm working, and what I'm supposed to be able to check on is not responding. So this is a good thing. Okay, changing gears. Now that we got the networking stuff handled, I need storage. Now, I'm lazy, so I just made the proxy server an NFS server as well because it's got an interface on the private network. So I spun up a 200 gig drive, attached it, formatted it, and then I'm going to export it. So create the directory var export. I'm going to mount dev vdb1, which is my secondary hard drive, on var export. I see that there is space available, so it mounted correctly. I gave this presentation at a Red Hat users group, and somebody was like, what? You can do that? Has anyone else done this where you look at the mount table, etc m tab? The last line of the mount table gives you the syntax for the last mount that you created. So I did tail-1 etc m tab, and it shows me that I'm using dev vdb1 mounted on var export using ext4 with these arguments. So read write, security label, relative A time. So I'm lazy. Tail-1 etc m tab, redirect that into etc fs tab as an appended thing, and man, you're done. You don't have to go and worry about, oops, did I fat finger it? So there it is. That's what it looks like. Now I'm going to install NFS utilities. This is fairly straightforward. If you've ever set up an NFS server, you run these commands, you make the directory. Now, when I got to this section of Ryan's documentation, I completely cringed. Can anyone tell me why? Yeah, right. Ugh. This one made me cringe, but then I was like, okay, this is a development environment. I'm doing production style, but in the real world, there are some additional steps, but it's it's time consuming. You got to figure out which user is supposed to. So for now, I recognize this is ugly. I recognize that I would never do this in an actual commercial production environment, but for now it works. So I create that. I edit the etc exports file, say I'm going to share etc export registry. I'm going to do read write, no root squash. Now I'm doing the no subtree check and no write delay. The no subtree check is primarily for security more than anything. But I'm also limiting it to only access from the 192.168 network. Then I do export FS. Make sure that NFS is enabled in the firewall, and it is for the internal network. And I'm going to add, so let me go back. All right, so I added NFS, I added RPC bind, I added mount D, and then I made sure that the service was started. And sure enough, I was able to mount it. I could look at the mount, and I'm in good shape. So that works. And you can see that it's 200 gigs that's available. So we're good there. Unmount that. Now, whoo, man, we've done a lot, right? We've had to set up the networking. We've had to set up the operating system. We've had to set up the proxy server. We had to set up HA. Done all this kind of good stuff. Now let's get to the actual nuts and bolts of OKD itself. So first thing is I download the installation software and the client software. The installer is literally that. It is the installer so that it's going to go out and talk to the various nodes. The client is for managing your OpenShift or OKD environment. So I downloaded those two. I just went to the GitHub for OKD. You can go to releases, find it. This is an older release. I know, I recognize we're up to like 4.17, I think now. But so there I found the, this was the client tools. So I found the client tools for x86 64 Linux, downloaded it. And then I did the same thing for the client, the installer, downloaded them, unzipped them, in this case, TarX ZXVF. And then I installed both OC and kubectl to user local bin, and you can see that now those files are available to anyone. Did the same thing with the installer. So now the OpenShift installer, I used sudo install to user local bin, and now they're good to go. Now, you can use an existing install config YAML file. That's what I did. I just snagged the one from the OpenShift GitHub repository. Or actually, I used the one that Ryan had done in his repository. I modified it for OKD versus OpenShift. And the main thing that you want to do is, when you're editing the file, change the networking type. So the default is, the default is, I think, OpenShift, and you need to change the network type to OVN Kubernetes. And that's about it. Make that change. You can create what is called a pull secret. So a pull secret is basically just telling your cluster, your OKD or OpenShift cluster, like who it's going to register with. You can get one from Red Hat if you have a subscription for OpenShift. Don't. Because if you use the pull secret from Red Hat, your OKD cluster is going to register with redhat.com, and it's going to take one of your subscriptions for OpenShift. So I recommend against that. What you can do is you can put the string that you see right there into your install config YAML, and OKD will go, oh, okay, I don't need to register. So that's an important one. The documentation is actually really clear about the fake string. So just put that into your the pull secret, and you should be in good shape. And this is what that looks like. So you look at the file, and down at the very end where it says pull secret, you just put that little text string in. The installer recognizes this is not real. I don't need to actually go register with Red Hat. Now what you need to do is you need to create an SSH key. I recommend that you use ECDSA, but whatever floats your boat, right? The default is that it'll use ID RSA, which I don't really like. But run that, create the key, grab that, and copy and paste it, and then you're going to add that into your SSH key for the installer file. And that is the SSH key that is going to be used throughout the entire cluster. So make sure that you use the right one. Now, when you create your installation files, note that it will delete your install config.yaml file. Ask me how I know. I cussed a lot when I realized that, because I had done all this work and I got it all set up exactly like that. And then I ran the installer and I went to go look and it was gone. So be aware that that'll happen. Back it up. Just make a copy of it somewhere. And the way that you do that is I did a directory called OKD install. Copy my file into that directory, not move. Copy your file into that directory. And then run your OpenShift installer. You have to make the manifests first, and you have to tell it where we're going to put them, and it will write them out into OKD install /manifests and OKD install /OpenShift. If you don't want your control plane nodes to be schedulable, like you're using little control plane nodes and maybe big worker nodes, and that's a legitimate way of doing things. You can edit the config file, the cluster scheduler config file, so that master schedulable is set to false, and this is what that looks like. See, I've got master schedulable set to false in that file. Now what you're going to do is you're going to create the ignition configs. When you install OpenShift or OKD, there are going to be configuration files, ignition configuration files that are going to be for your worker nodes and your control plane nodes and even the bootstrap node. And so to create those, you can run OpenShift install create and ignition configs in that directory, and it will spit them out. And you can see, there they are. So you can, let's see, there we go. So I did a find, and so you can see there's the bootstrap ignition, the master ignition, the kubeadmin file, etc., the worker node ignition file. So all that stuff's there. It's ready for you to do the installation. Now, I'm going to copy my ignition files over to my web server, but I did like just SCP. The permissions on those are wrong. You'll notice that by default, it's read write for the owner and read for the group. That doesn't do you any good because Apache is not the owner or the group. So when you try to read it from an Apache web server, Nginx, or whatever, it's not going to work. Ask me how I know. So go through and make the permissions correct and then copy them. You can put those files on any web server that the installer has access to. In my case, since I had the my workstation attached to both networks, I was just like, stick it in varlog or var-dub-dub-dub HTML. But I could have done it on the proxy machine or whatever. So I copied them. Make sure that you can click on them. In other words, make sure that when you click on them, you can actually download them. And then you download the ISO file for the OKD installer. I use Brasero on my workstation. And so I used Brasero. I found the live ISO and clicked on burn. In my case, because I was doing this on physical machines, I just plugged a USB CD or DVD-ROM drive in. You can set this installer up to PXE boot. You can use the vmlinux and nitrd.image file. In fact, you can get really granular on the way that you do that. I didn't want to mess with that, so I just said, you know what? I have a DVD drive and plugged in each one of them. And that is what my little home lab looks like. They're my little Intel NUC machines, and I literally plugged my DVD drive into each one of them. And when I did, I got a screen that looks like this. And I know you can't really see it that well, but it just says OKD installation. And you're like, yep. And you let it boot up. And then it will come to a splash screen where you have the option of passing installer information to the command line. You can't see it real well right there. Oh, wow, you can't see it there either. But basically what you do is you do sudo CoreOS installer, tell it what drive you're going to install on, and you tell it which one of the ignition files you want to read off the internet. And then, or off the network, and then you say, I'm going to use the ignition installer. I had to physically do that, type that out on each one of the machines, but it only took, a few seconds. And as soon as that happens, I do control plane node ignition files, and then I do worker node ignition files, and then I did a bootstrap node ignition file, because the bootstrap node is the one that you bring up first, and then it can manage the rest of the cluster, or manage the installation of the rest of the cluster. So install those, away it goes. You can see it pull down the image file off the internet and then write it out to the disk. Now, when you're doing that, it doesn't show you a lot of stuff on the screen, right? And so I was initially, like, wow, I'm watching, lines splash by on the screen. But you can run OpenShift install -- directory, whatever your directory is, bootstrap complete log level debug. And what'll happen is it'll actually, on your bootstrap node or on your installer node, it'll start writing to your screen, because the installer will listen to all of the nodes, all the ignition nodes and the worker nodes, and it'll write it all out to your screen so you can see what the progress of the installation is. So, and that's what that looks like. It'll start splashing stuff across. And then at the same time, you'll see on the actual worker nodes, you'll see, the system messages come up. You'll see the systems. It's pretty cool, because you'll see the systems will say like, hey, the ignition fetch service from whatever your IP address is running. And after a little while, you'll see those green OKs, and it'll say, yep, we're done installing and the system is up. Right there, I got some green on the HAProxy. Now that's just the bootstrap node, but basically the bootstrap node comes up and the HAProxy goes, oh, okay, I see that now there is traffic on the cluster. It's only the one node. But then after a little while, bada boom, all the rest of the nodes eventually come up, or at least I should be clear. First thing that happens is your control plane nodes come up. The worker nodes come up later. But what's cool is the installer, when it gets done, it'll tell you, I don't need the bootstrap node anymore. I only used it for installation. So you can take that out of the HAProxy. In fact, you can nuke that virtual machine or that physical machine. Restart the HAProxy when you take it out. And now you can see, well, I've got control plane nodes, but I don't have any worker nodes. Now I'll run the installer again against that directory, and I'm going to say, wait for install to complete. It's not very sexy, but you watch what's going on, and it'll go by, and finally it'll pop up and it'll say that it's done. When that happens, you can log into whatever that workstation is and authenticate to the cluster. The way that you do that is you use the kubeconfig file. Make sure that your identity is set up correctly so that you're being identified to the cluster. And then you have to approve certificate signing requests. And you're going to have to do that a number of times, because when you're building an OKD cluster, it's going to create a bunch of self-signed certificates. And in order for the cluster to communicate using those self-signed certificates, you need to say, you need to tell the control plane, yes, those are valid. I see the certificate signing request and I acknowledge them. And so the way that you do that is you can export that kubeconfig file on that you can export the values in that kubeconfig file that's in your installer directory. You can do OC who am I, and it'll show you that, yep, if you've exported the values in that file, the cluster recognizes you as the admin. You're going to see a bunch of CSR commands. You're going to run that command it's in the documentation. You're going to basically have to pull out the requests and then pipe those to OC Atom certificate approve. You're going to have to do that a couple of times. And when you do, all of a sudden, SSL is going to start working once you've approved all of those. So you can see you have to do it a couple of times. But then, boom, my control plane nodes are up. I can do OC get nodes, and I see at least that part of my cluster is done. But again, all the worker nodes are not ready yet. So you wait for a little while. Once those certificates or those SSL requests have been, the certificate requests have been approved. After a few minutes, the worker nodes will finally come back up. And like this screenshot, they weren't all the way back up yet, but I wanted to point out that once you get through all these steps, then the entire cluster comes up. And because we're using that HAProxy for redirection of all the traffic across those control plane and worker nodes, it just starts working. It's pretty cool. Now, you need to use the NFS storage for shared storage. And the way that you do that is you use OC edit configs image registry operator OpenShift.io. And when you do, it looks like a Vim session. And what you'll do is you'll change the management state from removed to managed. So basically you're telling the OpenShift cluster, no, we do want to manage storage. And then in the storage section, there's a blank section. And so what you do is you replace that to, you set up a PVC claim. Whoops, sorry. You set up a PVC claim. And once you save those, you can see that all of a sudden the storage becomes available. That storage is being used for the image registry. So as you're loading software into your OpenShift or your OKD cluster, it'll go onto that storage. You can OC get PVC, blah, 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 and you'll see that it is pending. And there is a persistent volume claim document that is in the documentation that you see in the GitHub repository. So you just have to set the correct IP address and the like shares, registry, whatever. And once you run that OC apply on that file, all of a sudden that persistent volume claim is created. And then when I do the OC get PVC, you'll see that it's bound. And now there's 100 gigs free for images for OpenShift. And after all that's done, you'll see that the installer finishes and it says you can log into the console with the user kubeadmin and the password, blah, blah, blah. It was generated dynamically. So you go to that URL that it gave you, log in, and you have a functioning OKD cluster. Now, that was 41 minutes. In the real world, it's going to take you probably an afternoon to make all this stuff happen. But these slides are available. You can also go to Ryan's GitHub repo and you can follow along with what he's doing. But y'all, I'm not going to lie. I fought and fought and fought to try to get OpenShift installed on bare metal for days and days and days. And I kept running into all kinds of weird issues. This process works. At least it works for me. And it worked using kind of cheesy old Intel NUC hardware. Like it just worked. So hopefully all of this made sense. If you didn't absorb all of this stuff in 41 minutes, like good, because if you did, you would be a freak of nature. But hopefully you at least understand all the different steps. And this should be a reference that you'll be able to do if you want to do this in your home lab. And with that, that's a wrap, y'all. We went from 0 to OKD in 42 minutes. I hope you've enjoyed this. Was this helpful? Did it at least like make stuff clear? All right, cool. Thank y'all so much. I appreciate it. And if you have any questions, feel free to let me know. I forgot to put my contact information on there. I'm real easy to reach, y'all. I am thomas@redhat.com. So if you have any questions, don't hesitate to drop me a line. And with that, I cannot believe I made it with 2 minutes to spare. I need a round of applause just for not going over. Thank y'all so much. I appreciate it. Yeah, question? Yeah.
How are you handling storage? This may just be OKD. How are you handling storage in containers?
So the question is, how are you handling storage in the containers? Totally depends. And I know that's a horrible answer, and I apologize, but it really does depend. What is it you're trying to do? Are you trying to do ephemeral containers that like are just applications that I don't care if they get nuked? Or are you trying to do like application services that need to talk to some sort of a storage backend, like a database or something? Or are you doing like, I need the application to have permanent storage inside of it? It kind of depends on what you're going to do. But you saw me create the persistent volume claim text file, the XML file. Depending on what storage you have available, whether it's, you can do things like Ceph storage, you can do object storage in like AWS, so S3. You could do NFS storage. So it kind of depends on what your technical stack looks like, what your comfort level is, and what the role of the storage is. But having said all that, as kind of random as that is, the short answer is create a persistent volume claim pointed at whatever you're comfortable with, and make that persistent volume claim available to the applications. Does that make sense? Okay. Any other questions? Yes, sir.
Is OKD an acronym? And if so, what does it stand for?
I think not. Like, I think that we originally all thought that it was the OpenShift Kubernetes distribution. But I've actually had people in the OpenShift BU say that is not true. It's just a thing we came up with. And that's it. That's my time. Yeah, I think it was OpenShift Kubernetes distribution, but I don't know. We just call it OKD now. All right, y'all. Take care. I appreciate it.